Hey everyone! Have you ever wondered how our brain really works? This episode is about one of the most ambitious projects in the history of neuroscience, the Human Connectome Project. The purpose of the project is to help show us what's happening under our skull by building a detailed activity map of the human brain. This would enable research into brain disorders such as dyslexia, autism, Alzheimer's, and schizophrenia. A connectome is shown here. It's a comprehensive map of the neural connections in the brain and can be thought of as its wiring diagram. The goals of the Human Connectome Project are to number 1, provide a compilation of neural data, 2, offer a simple way to view that data, and 3, discover new information about the human brain. According to the U.S. National Library of Medicine, the NIH Neuroscience Blueprint announced a competition for the Human Connectome Project, with the overarching objectives of acquiring, analyzing, and freely sharing information about brain circuitry and connectivity gathered by non-invasively imaging healthy young adults. The research done at the project has opened further investigations into blindside and sight restoration, connectomes related to anxiety and depression in adolescents, detection of early psychosis, and connectomes for brain aging and dementia. These examples demonstrate that brain-related research is not new, yet there is still so much the scientific community doesn't understand about the brain. Imagine how many new treatments, medicines, companies, and technologies will arise when someone is finally able to map the circuitry of the healthy adult human brain with a level of detail the world has never seen before. The word connectome is derived from the study of connectomics. According to Omniscient Neurotechnology, Connectomics is the big data approach to constructing and analyzing a computer-generated map of the brain's functional and structural connections. The word connectomics is related to the word genomics, which is the use of big data to study genetics in organisms. Big data is used to analyze the massive datasets needed to construct a digital map of the human connectome. Here's a clip from 2019 of how the Human Connectome Project got started.
Picture is from a Nature paper published by the Human Connectome Project. And what they did was began to try to utilize sophisticated imaging techniques and sophisticated machine learning techniques to try to define how many parts of the brain were there. This is a question that people have been working on for a long time, dating back to at least 1908, when a man named Brodmann determined there was about 47 areas in his estimation. We now know that the brain is more complex than that. As the Human Connectome Project showed, it's at least 180 areas that are uniquely different from each other.
Dr. Michael Sugrue is an internationally recognized neurosurgeon and researcher in connectomics and co-founder of Omniscient Neurotechnology. The Human Connectome Project has led to follow-up research projects that have attracted investment of over $1.5 billion from various U.S. federal agencies. However, today I will only talk about one, the BRAIN Initiative. An initiative called the BRAIN, or Brain Research Through Advancing Innovative Neurotechnologies, launched under former President Barack Obama. Millions of dollars of public funds were spent on research looking at the human brain and all of its inner workings. The aim is to learn about the brain by creating the most detailed maps of its connections and injuries. The project is gathering information from people of different ages, brain types, and neurological issues, and has already helped in the understanding of the brain's biology. The BRAIN Initiative was launched as a response to Obama's executive order of April 2013, which mandated the creation of the BRAIN Initiative. Here's a statement from former President Obama made at his 2013 State of the Union address. "If we want to make the best products, we also have to invest in the best ideas. Every dollar we invested to map the human genome returned $140 to our economy. Today, our scientists are mapping the human brain to unlock the answers to Alzheimer's. Now is not the time to gut these job-creating investments in science and innovation. Now is the time to reach a level of research and development not seen since the height of the space race." The BRAIN Initiative includes key investments to jumpstart the effort to the tune of $500 million, strong academic leadership, public-private partnerships, and maintaining highest ethical standards. In this clip, President Obama added this.
Imagine if no family had to feel helpless watching a loved one disappear behind the mask of Parkinson's or struggle in the grip of epilepsy. Imagine if we could reverse traumatic brain injury or PTSD for our veterans who are coming home. Imagine if someone with a prosthetic limb can now play the piano or throw a baseball as well as anybody else because the wiring from the brain to that prosthetic is direct and triggered by what's already happening in the patient's mind. What if computers could respond to our thoughts, or our language barriers could come tumbling down? Or if millions of Americans were suddenly finding new jobs in these fields, jobs we haven't even dreamt up yet because we chose to invest in this project. That's the future we're imagining. That's what we're hoping for. That's why the BRAIN Initiative is so absolutely important, and that's why it's so important that we think about basic research generally as a driver of growth.
As stated in the video, mapping out the human brain offers great benefits for humans. President Obama even feels that this type of technology has the potential to solve many global scale issues. Moving forward, I believe more world leaders will begin talking about these topics. Going back to what had sparked this BRAIN Initiative in the first place, our team asked OpenAI GPT-3 engine what it thought of the Human Connectome project, and this is what it had to say. The following is a conversation with an AI assistant. The assistant is helpful, creative, clever, and very friendly. The human says, "What do you think about the Human Connectome project?" The AI's response is, "The Human Connectome project has already informed our understanding of the brain, laying the groundwork for the development of treatments for brain diseases. However, this information is limited to the living human brain. The goal of the Neuralink project is to utilize brain uploading technology to capture neural level data from the brain. This data will then undergo analysis, a process that leads to a better understanding of the brain structure and behavior." Then the human asks, "So how will this affect us in the future?" The AI's response is, in the future, using this technology will no longer require an autopsy of the human brain. In fact, it will also permit researchers and others to view the internal structure of brains of deceased humans with intact bodies. It will allow us to brain time travel for the first time in history, reverse engineering our brains by the minute. And after asking for some elaboration, the AI responded with this technology, we may one day be able to access a specific memory of someone, view their personality, and many other things. In the distant future, we will be able to download our memories, knowledge, and learn skills. By comparing the life experiences of everyone, we will get everything we want." Pretty interesting thoughts from OpenAI's GPT-3. Moving on, some of the best in the field have expressed the benefits of understanding more about the brain and how with enough time and resources, we'll see positive effects on those with neurological disorders. In this clip, a few scientists explain the complexities of mapping the human brain.
We collected data from 1,200 individuals. We have them do different tasks in the scanner, things like a memory task, emotions on faces. Those same regions of the brain seem to be forming networks.
Brain structure is wired by its experience, but we have no idea in what form that wiring diagram has that information.
And that's the big puzzle. To see how that translates into individual nerve connections, you need to look much closer than David or Deanna's technology can go.
Down to the level of individual neurons.
2 quadrillion times smaller.
There are around 86 billion neurons in the brain. Brain-machine interfaces use electrodes to translate neuronal information into commands capable of controlling external systems such as a computer or robotic arm. So imagine having to map out 86 billion neurons down to each individual neuron. Fortunately, based on the latest scientific developments in the field, it appears that may not be very necessary. Regardless, how close are we to this complete mapping?
So, how close are we to mapping the human brain?
The biggest barriers keeping us from building a highly detailed human connectome is really technology. Even my scientific lifetime, the progress has been exponential. So I wouldn't be surprised in 10 or 20 years if we had a sort of dramatic leap in our understanding. I think we may never have a map of every connection in the human brain in the sense of understanding exactly how they interact together to give rise to exactly all the human behavioral and cognitive and emotional abilities. That's a tall order, and I'm not entirely convinced that we will ever be there.
Theoretical physicist Michio Kaku is optimistic about such a project. Here's what he had to say.
We'll explore the universe as pure consciousness, traveling at the speed of light, looking at asteroids, comets, meteors, and eventually the stars at the speed of light. All of this within the laws of physics. When will this happen? Perhaps in 100 years. The Connectome project will map the entire brain in about 100 years. And then what do we do with it? I say we shoot it to the stars.
In modern times, the human brain has fascinated many, yet its wonders are still not fully understood. The results of the Human Connectome project may shed light on key aspects of the human brain and help people with neurological illnesses receive better treatment. Researchers hope to find new methods for testing drugs directly on the brain instead of through animal trials. To simulate the conductivity and stretchiness of brain tissues, conductive materials are needed, and for this project, a new class of materials is being investigated. I'm looking forward to continue following progress related to brain mapping. My name is Ryan Tanaka. This episode's script was primarily written by Jonathan Nottingham, and the video is edited by Omar Olivares. Thanks for watching. If you're interested in helping us grow Neurapod, please go to www.patreon.com/Neurapod or clicking the join button below the video. Your support helps us increase the quantity and quality of our videos. Thanks again.